Dear students, today we are going to determine the Planck's constant. Along with that, we are also going to find the wavelength of the IR radiation by using the LEDs. So here is the apparatus, and here we have the experimental procedure, in which the H is going to be given by E by C into lambda V average, where E is the charge of the electron, its value is 1.6 into 10 raised to minus 12 coulomb, and C is the velocity of light, that is 3 into 10 raised to 8 meter per second, and lambda is the wavelength of the light what the LED is emitting, and V is the knee voltage, okay, or the peak voltage what we will call here, okay, peak voltage of the LED whatever we have used, okay. And along with the Planck's constant, we are also finding the wavelength of an IR LED. For that, we have the formula that lambda IR is going to be given by lambda V average divided by V IR, okay. And this is the circuit diagram, and this is the experimental kit in which we have to realize the circuit, okay. We will just see how to do the circuit connections now. These are the connecting wires by which we are going to do the connections. Here if you just see, we have the AC source. Here also we have a AC source, and this is the circuitry part. Here this is the circuitry part, but there is no connection here between the source and the circuitry part. So but first we have to build the connection between the source and the circuitry part. So I will use the connecting wires to connect them. So now the source has been connected to the circuitry part. Next here we have to connect a voltmeter, and here we have an AC voltmeter. I will just do the connections from negative. So this is about the circuit connection of the experiment. Next we have to connect the LEDs here, okay, and we have to take the readings. Okay. Now this is the circuit connection. We have on the circuit now. Now take the different LEDs which have been given for you people. Just take one by one and insert these LEDs into the pin here. So take care that these two leads should run in between these two holes, and this tongue should run here in the notch, okay. So this is how you have to make the LED connection. So now as you just observed here, the voltage of just allow for a few seconds so that the voltage will becomes almost a constant. Now this will be the peak voltage, and this value we have to note it down. So I will just here note down the maximum value. It is giving 2.16 for red color. Similarly now we have to do it for other LEDs. This is a yellow one, orange one, okay. The orange, it is giving the value. If you just wait for some times, okay, it will give the value. Just note it down, the 2.25 is the maximum. Next, this is the green one, so 2.32 it is giving maximum. Next, the blue one, it is 3.70. Similarly, we have to find what is the voltage, the peak voltage for an IR LED. So IR LED, it is radiating the IR radiation. So since our human eyes are not capable of recognizing the IR radiations, we cannot see any light over here. We can just take the voltage. So it is giving 1.34 as the maximum. So this is about the conduction of the experiment. Next, how to do the calculations. So here in the tabular column, as we have just noted down the independent parameter, that is the voltage, and dependent parameter is the wavelength, as the values has been already given. Now we have to complete the tabular column by doing the calculations. So here the first column we have to fill here is the lambda into V, where lambda is 6200 angstroms for red color, and the new voltage for the red color is 2.16. Just do the multiplication and fill the value here. Similarly, for each wavelength we have to multiply the voltage and we have to tabulate it. And next we have to find the energy what it is emitting, the energy of the photon what it is emitting by the LEDs. That can be calculated by the formula, the energy is equal to E into V, where E is the electronic charge and V is the peak voltage what we have got. Now just multiply both the things, that is E with V. Okay, you will just enter the values here. The values will be in the order of 10 raised to minus 19 joules we are going to get here. And next here the last one we have the frequency column, where frequency nu is going to be given by C by lambda, where C is the velocity of light and lambda is the wavelength of the light which is emitting by the LEDs. So calculate the C by lambda and tabulate the values in the tabular column. After filling the tabular column, find out what is the average of this lambda V, and you just note down the lambda V average here. Next, the further calculations we can do by substituting the lambda V average in the given formulas H and lambda IR. Okay, so we can get the H value, the calculated H value by substituting the lambda V average value in the formula, and the wavelength of the IR radiation we are going to get by substituting the lambda V average value with voltage of IR radiation, the peak voltage of IR radiation in this formula. By calculating the values we will get the answers. And here we are going to calculate the H value by graphical method also. Okay, so for that one we are going to plot the energy versus the frequency, energy versus the frequency, where energy will be taken along y-axis and frequency is taken along x-axis. Okay, whatever the values we have got here in the E column and mu column, we have to plot the graph for these values in the graph sheet. So we are going to get 4 points and draw an straight line, average straight line in the graph, and if you just find the slope will give us the Planck's constant. Okay, because E is equal to H nu we have, so E by nu will give us the H value. Okay, by this way we can find the Planck's constant by graphical method. Now enter all these results, okay, in the result column, and this completes the experiment.